Good evening, Zaid. Everything good?
Yes.
All right. We are waiting for the students to join in. All right.
Yes.
Till then, you can revise. Hello, Sahel.
Hi, sir.
Everything good?
All great, sir.
All right. Revise everything?
Yes, sir. Just a bit, not much.
All right. And the exercises are done of NCRT homework?
Yeah, sir. Did a few of them. Yeah.
All right. Any doubts from that?
Not really, sir. It was I referred to my notebook, school notebook, where I have already completed it, so it was easy.
All right. All right. No issues. And do you have any exams coming up in the next month or?
The school has
Can
not
we-
started yet, so I'm not sure. Maybe after a month or maybe after 2 weeks, maybe I'll get to know.
All right. As soon as you get the information, please convey that to me. All right. So that we can plan accordingly.
Sure, sir.
All right. So this chapter will be finished in next classes. All right. All continuity and differentiability. Then
There's
two
two
more.
classes will be over, right?
Sorry.
Within 2 classes, this chapter will be over, I guess.
Yes. Today and next two classes. All right.
Okay.
And after that, we'll be taking 2-3 classes for application of derivative, then integrals. All right.
Okay. Got it.
So let's wait 2 more minutes. All right. Then we can start the class. You guys can revise till then. Let's see what is there in today's class. Second order derivatives. All right. I hope you guys are all clear about trigonometric differentiation, logarithmic differentiation, parametric form. Yes or no?
Yes.
And you guys completed the assignment also?
Yes.
Any doubt from the assignments?
No, sir.
No. Let's Sahel.
I didn't complete all the assignments, so the latest ones I have to complete.
All right, but please do complete that. That carries a lot of important questions. All right.
Right, sir.
So what is second order derivatives? Very simple. If you have a function y, then differentiation or derivative of y with respect to a variable x is dy by dx, or we can say f dash x or y dash or y1. All right, all of these similar names for same thing. If dy by dx is again differentiable, that means we can differentiate this, then d square y upon dx square is the second order derivative of y, and we can say this is y double dash y2 also. And remember this, d square y upon dx square, this is absolutely not equal to dy upon dx whole square. All right, here this 2 means order, how many times you have differentiated. But if you write like this power, then this is you differentiated, then squared that. All right, Sahel, this is clear what I'm saying?
Yes, sir. So
All
one
right,
doubt,
there.
sir, like if we differentiate d into 2y divided by d by dx square, right? So will 2y come outside?
No. See, this is just a way to represent things. All right, what I mean
Okay.
by this, if y is x square, I ask you to
Okay.
find dy by dx. What this means? This means that
With
d
2x.
upon
Right.
yeah, d upon dx is an operator, right?
Okay, okay,
Operator of
okay.
differential, like plus minus. Same way, if anybody asks you to find d2 upon dx square, that is an operator. Operator of what? Second order derivative. That means we have to differentiate 2 times.
Okay, got it.
This is a symbol, nothing much.
But the operation
Alright.
is same thing, what we did earlier.
Yes, absolutely.
Just we're calling
everything
by
is same.
another name.
Yes. Why we're
Got it.
calling this another name? Because this demands you to differentiate to d2. This is d1.
Okay, so how
Alright.
would we do that? Like how do we differentiate twice?
We'll come to that. Don't worry. All right.
Okay, sir.
This is just, we are just introducing what second order derivative is. All right. Why I'm saying this is not equal to this? Because dy by dx we know how to find, right? If you square this, then something different comes. But if you write d2y upon dx square, something different comes. All right. This is clear,
Right,
everyone?
sir. Yeah, sir, clear.
All right. Hello, Pinza.
Hello, sir.
Everything good?
Yes, sir.
Did you complete all the assignments?
Yes, sir.
Any doubts from that?
No, sir.
All right. So today we started second order derivative. So what is second order derivative? If you have a function y, then if you differentiate it first time, then we write that as dy upon dx. If we again differentiate this function, then this is called second order derivative, and we write this as d2y upon dx square. All right, and remember this, this is not the power, this is just a denotation. All right, so you can write this also, d2y upon dx square is not equal to dy upon dx whole square. This is absolutely not equal. All right,
Okay. Yes, sir.
please note it down, everyone. Done, everyone?
Yes.
All right, Sahel. Sahel Kinza, are you done?
Yes, sir, done.
All right. So now the question arises, how to do this? Very simple. Kinza, you are done, right?
Yes, sir.
So very simple. If you have y equals to x square, what will be dy by dx? What will be dy by dx?
2x.
2x, right? What about rest of you? You forgot everything in vacations, right? Now, Sahel, how to do this? If you differentiate this again, then how we write d upon dx of dy by dx? We assume this is a function, right? Because this is a function. We don't assume, we know this, right? So d by dx of this function, so d by dx of 2x. So this we write d square y upon dx square, which is equal to differentiation of 2x's to, this is the final answer. All right, absolutely right, Zayed. Sahel Kanza, is this thing clear?
Yes, sir.
Clear, sir. Yeah.
Right, very simple, just differentiate 2 times, you'll get the answer. All right, note it down if you want.
So it's like function upon function, right?
No. Function of a function is different. Function of function, again, remember the movie Conjuring? One body, inside that is a different soul. But this is like in Hinduism, like Punarjanam thing. this function died, we differentiated, and this became this function in another life. Now we are differentiating. All right, Sahil?
Right, sir. I'll just note it down.
Everyone is clear about this or not?
Yes, sir.
Yes, sir.
To solve this question, y equals to x to the power 6 plus sec x. Find d2y upon dx square. All right. Or you can say y double dash or y2. If anything is written, they mean the same thing. All right. Raise your hands when done, and I need the answer on chat. Can you not get your answer? Kinza, can you solve this? Let's see. dy by dx, this is 6 x raised to the power 5 plus what is the differentiation of sec x?
So Cx sin and tan x.
Right? So again, if we try to differentiate this, so differentiation of this will be differentiation of this. And you have to use product rule here. So t square y upon tx square will be equals to differentiation of this is 30 x raised to the power 4 plus we have to use product rule here. So sec x differentiation of tan x. What is differentiation of tan x? Sec square x
6 square.
plus tan x into differentiation of sec x is sec x tan x. So this is 30 x raised to the power 4 plus sec cube x plus sec x into tan square x. Let's see. Z, that is not 35, that is 30. The rest of the answer is correct. Sahel, very good. Kinza, this is clear?
Yes, sir.
All right. Next question. If y equals to a sin x plus b cos x, then prove that d square y upon dx square plus y equals to 0. All right. Most of the times in this type of questions, you will always get proof that. So don't need to like think a lot about this. Do what? Just find this value, right? Y, add them, you'll automatically get LHS equals to RHS. All right, start with LHS, find d square y upon dx square, add y with that is the LHS, you'll automatically get 0. All right, everyone?
Yes.
Yes, sir.
All right, Zaid.
Done, sir.
All right, Sahil. Kinza, this is done.
Not yet, sir.
All right, 2 more.
Done, sir.
All right. No need for me to solve this, I guess. Next question. If y equals to 3 e to the power 2x plus 2 e to the power 3x, prove that d square y upon dx square minus 5 dy by dx plus 6y equals to 0. All right. Same way you have to solve this. Start with LHS, write down all the values, you will be done and getting the 0. All right. Note that you don't have to use log here, right? You can simply differentiate. All right, Sahel. Sahel Kinsa, have you solved this?
So can you solve this one, sir?
All right. Kinza, what about you?
Almost done, sir.
See, if y is this, then dy by dx will be Sahel. Sahel, can you differentiate this function?
Yes, sir. This is done, sir.
Tell me what will be the differentiation of this?
Sir, I use log, sir. But then
All right.
I was,
How?
yeah. So it will be taking log first, sir, before it will be log y equals log of 3 e raised to 2x plus log of 2e e raised to 3x.
Right. See,
Yeah.
I told you this when I was talking about logarithm differentiation, that if functions are added, then there is no point in taking log, right? Because
Okay.
there is no formula for log m plus n. We have formula for log mn, log m by n, log m to the power n, and everything. But we do not have a
Okay.
formula for log m plus n or m minus n, right, Sal?
Right, sir.
So if you still want to take log, what is the trick? Assume this is u, this is v, find du by dx, dv by dx, and then you can solve.
Oh, I forgot to
Right?
take that du. Okay, okay.
Right,
There I
right.
got
Yeah,
stuck.
now you remember this. But you can
Yeah.
directly differentiate. You like this is not very complicated to differentiate. This is, let's break it down. This is differentiation of 3 e raised to the power 2x. This differentiation of 2 e raised to the power 3x. We can do this using chain rule very easily. So 3 is outside. Differentiation of e raised to the power 2x is e raised to the power 2x, but differentiation of 2x is 2 plus 2 e raised to the power 3x into 3. This thing is clear or not? Anyone?
So can you explain again, like, how did we get 2 after e raised to 2x? Like,
Remember that chain rule. This is conjuring movie. E raised to the power x. We
yeah,
should have
2x is this whole idea, right?
right.
Yeah.
So
Okay,
differentiation
x,
of
okay.
e raised to the power.
Okay, 2 into 1. Got it, got it.
Got it?
Yeah, got it.
So dy by dx is equals to 6 e raised to the power 2x plus 6 e raised to the power 3x. We can take 6 common. Now again we can differentiate, because in the question we need to find d square y upon dx square also. So this will be differentiation. Can I differentiate directly? Any issue? Anyone? Just tell me if you don't understand. This is e raised to the power 2x into 2 plus e raised to the power 3x into 3. Very simple. This thing is clear.
Yes, sir.
So now let's start with the LHS. The LHS is d square y upon dx square minus, what is the number here? 5. I think 5 divided by dx. And what is here? Plus. Can anyone tell me what is the question asking to prove what?
6y.
6y. So d square y upon dx square is 6 times e to the power 2x into 2 plus e to the power 3x into 3 minus 5. What is dy by dx? Dy by dx we have 6 e raised to the power 2x plus 6 e raised to the power 3x plus 6y. What is y? 3 e raised to the power 2x plus 2 e raised to the power 3x. So just add them, you'll get the answer. Right. This is 12 e raised to the power 2x plus 18 e raised to the power 3x minus 30 e raised to the power 2x minus 30 e raised to the power 2x plus 30 e raised to the power 2x plus 12 e raised to the power 3x. So 12 e raised to the power 3x, 18 e raised to the power 3x, 30, and 30 minus 30 is, sorry, this one is 3x. It's cancelled, and same for this. All right. This is 18. This thing is clear, everyone?
Yes, sir.
All right. Sahel, this is clear?
Yes, sir.
All right. So in this type of questions, always just write down LHS, find all these values. You will automatically get your answer. So next question. If y equals to sine inverse x, then show that 1 minus x square d square y upon dx square minus x dy by dx equals to 0. All right, I'll give you a few minutes for this also. All right, Zed.
Done, sir.
All right. Kinza,
No, sir.
are you able to solve this?
No, sir.
All right, let's see. So we have y equals to sine inverse x. So dy by dx will be
1 by root of 1 minus x square.
absolutely right. So what will be d square y upon d x square?
This I'm not getting.
All right. See, this is very simple. You have to use u upon v form here. Just 1 second.
Oh, yeah.
Right? U by v form. So 1 minus x square under root into differentiation of 1 is 0 minus 1 into differentiation of this will be again chain root. So 1 upon 2 under root 1 minus x square into minus 2x. All right. Do I need to write all these steps?
No, no.
All right.
Got it.
Upon v square, so 1 minus x square. So we can directly see in the LHS, we already have this multiplied with this. So we can throw this one to this side,
Yes, sir.
right? So 1 minus x square into d square by upon dx square equals to this minus and minus plus. This is 0. 2 and 2 is also cancelled. So x upon under root 1 minus x square. And under root like 1 minus x square we can write as y. So this is x y, sorry, x dy by dx,
Yes,
right?
sir. Yes, sir.
So just take it to this side and your question is proved. All right.
Yes, sir. Thank you.
All right, everyone, this is clear, right? This is the steps you followed. Sahel,
Yes, sir. I did that.
next question, last question on this. If x equals to under root a sine inverse t and y equals to under root a cos inverse t, then find or show that dy by dx equals to minus y upon x. All right. All right. Kinza, Sahel, have you solved this?
Yes, sir.
Yes, sir.
All right. So no issues with this question. How did you guys solve this? Like differentiated directly or you did any tricks?
So we took log.
Took log. Absolutely right. Sahel, this is clear?
Yeah, sir. Clear.
All right. So this is all about differentiation part. I hope second order derivative is also clear. All of you?
Yes.
Yes,
All
sir.
right. So this part is over. Next is continuity. So in homework, please complete the NCRT differentiation part, all the assignments also. Before we start with continuity, are you guys all familiar with limits? Yes or no, Sahel?
Familiar, sir, but need to revise a bit.
All right, Kinza.
Yes, sir.
So let me give you a quick revision for this. Then we can start with continuity. There are 4 ways to evaluate limits. 4 ways to evaluate limits. All right. What are the 4 steps? Direct substitution, factorization, rationalization, and we have standard limits or standard formulas. Right. If you are okay with all of these 4, then you can solve any limit questions that you can see. All right. So what is first? Direct substitution. As the name suggests, what we do here, put the value of x directly. All right. So what do I mean by this? If you have limit x tending to 2, x square plus 2. All right. So what is limit? Limit is we are trying to find the value of a function. Which function? This function. Where at x equals to 2. So this is read as x tending to 2, right? And tending to 2 is not equals to 2. What this means? If you have x equals to 2 here, tending to 2 means x is almost 2. Very, 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 very close to 2, but not 2. All right. This is clear what I'm saying? So the first step whenever to evaluate a limit question is to put the value directly. That is called direct substitution, and see if the value comes out as infinite or a good normal value. So if you put x equals to 2 here, you will get 2 square 4, 4 plus 2, 6. So 6 is a okay number, right? Normal number, right, Sahel?
Right, sir.
So we can directly put the value of x as 2 here, and the final answer will be 6. So we will say the limiting value is 6. I hope this is clear.
Yes.
Yes or no? All right. So let me give you a quick questions on this. Just give me a minute. Limit x tending to 4, 3x square plus 5x minus 8 upon x minus 5. I need the answer here from all of you in the chat. All right, Sahel. Sahel. Pinza, what is the answer here?
Minus 60.
Minus 60. All right, so no need for me to solve this. Next question. Limit extending to 0 under root 1 plus x plus under root 1 minus x upon 1 plus x. All right, Zaid. All right, Sahel. Pinza, what is the answer here?
2 root 1.
2 root 1. And what is the value of 2 root 1?
2.
2. All right. So this is about direct substitution. Whenever you see a question of limit, always put the value of x and see what happens. All right. The second is factorization. Suppose I give you limit extending to 2 x square minus 4 upon x minus 2. What is the first step? To put direct substitution in use. So putting x equals to 2 here, what we get?
So 0 by 0 form.
0 by 0, right? The numerator is 0, denominator is 0, right? Sahel, Pinza.
Yes, sir.
And what is 0 by 0?
Not defined.
Not defined, right? Nobody knows how we can say the value of 0 by 0. Nobody knows. So direct substitution is failing in this type of questions. So what we can do, we try to eliminate the factor that is becoming 0 in the denominator, right? 0 in the numerator makes us very happy, but 0 in the denominator does not make us very happy. So what we try to do, eliminate the factor in the denominator that is becoming 0. So limit x tending to 2, how we can factorize? This is x minus 2, x plus 2 on x minus 2. This we can cancel out. So now the question becomes limit x tending to 2, x plus 2. Yes or no, everyone?
Yes, sir.
Right. Now again we can put direct substitution, x equals to 2. So 2 plus 2 is 4. 4 is a good number. So we can directly write the value as 4. All right.
Yes, sir.
Right. Sahel, this is clear?
Yes, sir.
Note it down. I'll give you a few questions. All right, this is your next question. I need the answer in the chat from everyone. Sahel, try to factorize this. All right, Zaid. Sahel, Kinza, we solve this. Can you guys factorize this or not?
Sir, can you solve this?
All right. So limit extending to 2. First step is always direct substitution. So putting x equals to 2 here, 2 square is 4 plus 6, 10 minus 10 becomes 0. That is okay. In the numerator 0 is fine. But in the denominator also we are getting 4 minus 4, 0. That is where the trouble is. So how to factorize this quantity, the numerator? Middle term splitting. I hope you guys know that. Sahel, Kinza.
Yes.
Yes, sir.
So we can write this as minus 3x minus 2x plus 6. And in the denominator, this is x minus 2, x plus 2. Yes or no?
Yes, sir.
So this is limit extending to 2, taking x common, x minus 3, minus 2 common, x minus 3 upon x minus 2, x plus 2. So limit extending to 2, x minus 3, x minus 2 upon x minus 2, x plus 2. So this is cancelled. So limit.
So is it
extending to-
compulsory to take minus 3x and minus 2x only?
because that are the only numbers, right, which satisfy this equation.
No, like minus 6 and 1.
Let's see, x squared minus 5x plus 6. All right, if you write minus 6 plus 1, then yes, addition is minus 5x. But if you multiply these two, what you get?
Multiply what?
Multiplying
Oh,
these two
minus,
numbers,
okay. 6, right?
minus 6x squared.
Okay. Right.
But we need to get plus 6x squared.
Right.
Right, so you have to look for these small things. All right, Sahel.
Got it, sir.
So finally we have x minus upon x plus 2. Now we can put again direct substitution. So 2 minus 3 upon 2 plus 2. This is minus 1 upon 4. I hope this is clear.
Yes, sir.
All right, please note it down. Try to solve this question next. Limit extending to 1, x cube minus 1 upon x minus 1. All right. All right, Zahel. Sahel, I will solve this.
Not getting it, sir.
Just use this formula for a cube minus b cube. A minus b.
Yeah, I know that formula. I tried it.
Still not. So a cube minus b cube, you can write like this. So what is the value of a? X. What is the value of b? 1. Just put the values here. We'll get the answer. All right, Sahel.
I'll try again once.
All right, Kinza.
Yes, sir, done.
All right. What is the answer?
3.
Very good.
So my routed denominator, what should I do?
No, you don't have to do anything in the denominator, right? X minus 1 will be cancelled automatically.
Yeah, so okay, after cancelling, that's it, right?
Yes. After cancelling, nothing you have to do. You can just put the value directly, direct substitution. All right. Clear?
Right, sir. All right.
So this is all for today's class.